Greetings, 2%ers. Well, good news. We're going to dumb it down today and just stick with mechanical after my break I needed from my last series with that ABS system computer and all that. So we're going to get back to that. Don't worry. If I have to buy my own ABS computer to convince the guy to come back, I want to finish that. That was a good one. But if you watch that last video in the series, you know that I was interrupted in my brainstorming with a tow truck driver that dropped off a no start here. And I let the cat out of the bag in that video that this car does have a broken timing chain tensioner. Also, this car has an interference engine. So the purpose of this video is going to show how to diagnose whether you have damage on the interference engine as a result of a broken timing chain or belt. And yes, this car does have a timing chain in it. There is a myth out there that if a car has a timing chain, it will not be an interference engine. Well, we're going to prove conclusively that that is absolutely not true. And you can also Google it that it's not true. Before we start, there is one order of business to take care of, and that is we have some prizes to give away from the last video. In the last video, I asked my viewers, who I know many are acutely perceptive, what is different in the scene here versus the last, 6 years that I've been doing these videos. And very promptly, within minutes, George Bonnie 90 came up with the correct answer that the markers on the dry erase board of knowledge are on the sides of the board instead of along the top. So, as you guys are well aware, nothing is without purpose on this channel, no matter how minute it seems. And the point with the markers is that if you watch this channel long enough, you know that about half the time, whenever I reach for a marker when I'm using my dry erase board of knowledge, the marker is dried out, and it's very frustrating. So it turns out that if you store the markers with the point down instead of storing them sideways, that phenomenon is much, much less likely to happen. So the trick, by the way, on keeping the markers up there, I do not use magnets. I just simply use Velcro tape on the marker and the board. But that is the reason for that. I was just curious, given the fact that people notice all kinds of obscure things. They notice the jack stands moved locations. The time on my scan tool is 2 minutes off the time on the wall clock. I just wanted to see who would catch that. So George Bonnie 90 was the first. Now, I'm giving a runner-up prize to Vicarod, who was just moments after and wasn't first, but also got it right. And a third prize to John Fontaine, who noticed what I didn't even notice, and that is that I always used to have, my marker board came with 4 little black magnets on it that I never used ever, but I just kept them in the corner of the board. And I removed those magnets because I just figured, why are they there? And John noticed that the magnets were missing. I didn't even think of that. So John, you get a prize too. And the prizes are lifetime subscriptions to the paid channel at www.schrodingersboxqm.com. So you guys, if you're already members, you won't have to pay anymore. And if you're not a member, all you have to do is send me your email address and I will award your prize. You can find my email address by clicking on my name on any of the comments, going to the About tab, and you should be able to find my email address on there. Send me your email address and I will award you with the prize. All right, with all the housekeeping taken care of, let's go ahead, take a listen to this engine, and you're going to pretty easily be able to diagnose what the issue is. All right, as you can clearly hear, this engine has no compression at all, so it sounds like the starter is just free spinning. If you listen very carefully, you can hear a little bit of chain noise indicating that the chain is still connected somewhere. But the first step that you want to do is you want to determine, is this car a interference engine? So this is a 2004 Mazda Tribute, the V6 dual overhead cam. So the first thing we want to do is determine, do we have engine damage as a result of the timing chain failure on an interference engine. An interference engine is one where the valves come deep enough into the cylinder that if the valve train were to freeze in place because the belt broke or the chain broke and that valve train freezes in place, if the car is still moving, the pistons can come up and smash into the valves. And at best, if you're lucky, if you're really lucky, the valves just happen to end up in a position where none of the pistons will smash into them. If you are semi-lucky, the piston will smash into the valve, but maybe not damage it somehow, so that's pretty unusual. What usually happens when the piston jumps into the valve like that, it bends the valve. That's typically what happens. Worst case scenario is that the valve punches through the piston crown. And in that case, you've got a major problem because now you've also got lower engine damage, so you can't just replace the valve in the cylinder head and all that. So that's what we want to do. We want to determine, is there any damage to the engine, and if there is it only top end or cylinder head related damage with the valves? Is it bottom end damage, or is it both? So the first thing I'm going to do is, there's no point in doing a compression test. You could do a compression test. There's no point. There's no compression on any cylinders here. And the reason there's no compression on any cylinders is almost certainly because the engine is so out of time as a result of the timing chain failure that as the pistons are coming up, the valves should be closed, but they're not because the valve train is out of time. So a compression test is useless. What we want to do is we want to do a leak down test, but we have to modify the way we do the leak down test. Normally you would bring a piston to top dead center because your valves are closed, introduce your air into the cylinder and listen to where the air is escaping. If it's escaping through intake valve, then your intake valve bent. Through the exhaust valve bent. If you hear it through the oil pan, you must have punched a hole through the piston. On a blown cylinder head gasket, you would hear it going through the coolant. But we can't do it that simply because if we bring the piston to top dead center, most likely with this engine so out of time, one or both valves is going to be open now because it's out of time. As a matter of fact, probably on a dual overhead cam, the two cams are going to be out of time with each other, as well as out of time with the crankshaft. So what I decided to do, there's two ways that you can handle this. And what I did was I removed the valve cover off the engine, and we're going to take a look here and I'll explain the two methods that you can use in this situation to still be able to do your leak down test. All right, I took the valve cover off the engine, and very, very uncharacteristic of this channel, I will tell you, there is a subjective diagnosis I can make, and that is when I remove the valve cover gasket, I can just tell by the smell of the engine. I know this sounds stupid, especially coming from me, but I can just tell by the smell of the engine that there is some kind of major damage in this engine. There is a distinctive, very acrid, it almost smells like burnt toast. And I can just tell by smell that this engine's already got a big problem. Now, of course, I'm never going to tell a customer, hey, I smelled the oil and you need a new engine. So we're still going to do something quantitative here. But what I've done is I've wired up a remote starter, and I want you to take a look here. All right? As you can see, we still have the timing chain operating all of the components. You can also, I removed the spark plugs, and you can look in the spark plug hole, see the piston is moving too. So we've still got the timing chain operating everything. So that means that we need to consider how we're going to do this leak down test. One method that I can use for doing my leak down test is to make all of the valves default to a closed position. And that would be done by removing all the bolts, retaining the camshaft so that the camshaft comes out of place. That will prevent any lobes from pushing down on the valves. This is overhead cam design, so the cam lobes will push down directly onto the valves to open them. Removing that camshaft out of the way, even just a little bit, releases tension on all those valves, and they will default to a closed position. If I do that on both cams, all the valves will be closed. I can do my leak down test. It actually doesn't matter the position of the piston in that case because the valves are closed regardless of where the piston position is. The second method, and the one that I'm going to use, is I'm going to just use my remote starter, and I'm going to spin the camshafts into a position that I can see all of the valves for that cylinder are closed. So let me get a flashlight. Okay, I have no idea the numbering of these cylinders, but I'm just going to start with this one in the left here. Maybe there's numbering here. No, there isn't. So if we look very closely here, we can see on this cam lobe, for example, these cam lobes are egg-shaped, and the tip of it is well off of the valve. That means this intake valve here, this is going to be the intake side on the head, this intake valve is definitely closed. What I also need to do is take a look here. If we look at the exhaust cam for this cylinder, we can see the egg-shaped lobe on the exhaust cam. The tip of the lobe is pushing down on the rocker arm for the valve. Again, overhead cam design, no push rods here, so the cam directly pushes the valves down by directly pushing the rocker arm. We can see these are roller rocker arms, and the tip of the cam lobe is actually on that roller pushing that valve open. So what I need to do is reposition the engine just a little bit so that that comes off of the valve, like that. All right, we can see the egg shape of the cam lobe here. We are off of that exhaust valve, so the exhaust valves are closed now. I can look over at my intake camshaft, and I can see that I didn't rotate the engine enough, that the lobes for the intake cam are engaging the intake valves. So both the intake and exhaust valves are closed on this cylinder. I could have also hand cranked it as well, but this way is just a lot faster. So now I'm going to do my leak down test on this cylinder. There's a broken piece of timing chain guide right there in the front cover. Well, that don't look good. All right, I always put some anti-seize on my leak down or compression tester adapter to make sure that it doesn't stick in the cylinder head. Sometimes you remove the hose and your adapter stayed in the cylinder head, and my cheap one is designed to a point where I have a very hard time getting a socket around it, so just a little tip there. All right, now, when I add the compressed air in here, if there was compression in this cylinder, what would happen is it would probably, because we don't know if we're at top dead center, we're surely not, it would push the piston downward, which of course would rotate the engine on us. And if that happened, that's okay. I know there's compression in that cylinder, and I would just simply take my hand crank and manually crank the engine while there is pressure, air pressure in the cylinder, and just hold the engine in a position with the valves closed and check the leak down that way. We will not have to do that on any of these cylinders because you can hear no cylinder has compression. I'm going to hook up my air and turn it on, and you can see the gauge shows high leak down. There was no movement whatsoever of the engine. There is definitely, the valves are closed and we are losing air. You can hear it. Give you a listen. So the question is, where is that air escaping to? Is it going through the intake, the exhaust, through the cooling system? There was no overheat. The symptoms the customer described, he was just simply driving, pulling off on an exit, and immediately there was a noise in the engine, big puff of smoke, rather dramatic, he said, and the engine just immediately died, and he was able to coast it off to the side of the road and tried to start it and found exactly what we found here. So not an overheat condition, so we don't anticipate blown head gasket. So I don't think this is leaking into the cooling system. What I'm going to do is I'm just going to put my ear onto the intake, and it's not coming through the intake. The other thing that I can do is I can put my ear to the exhaust. That's underneath the car, so I'm going to go and put my ear to the exhaust manifold. Sitting at the exhaust manifold, there is no air coming out there either. Okay, so it's not going through the intake or exhaust valve, so that means that most likely we punched a hole in the piston on this, and that would of course be catastrophic. We would have to get a new engine for this guy. So what I'm going to do is I'm going to listen at the oil pan. So I'm going to get back under the car, listen at the oil pan. My ear is right at the oil pan. I got to tell you, I don't hear anything. You'll hear a hollow hiss of air. That only leaves one possibility. The only other place that the air could be escaping would be into the adjacent cylinder. So I'm going to put my thumb in here. Oh, you can absolutely feel air coming out of the adjacent cylinder. So let me do a quick lookup on these cylinder numbers. Okay, so the cylinders are numbered 1, 2, 3, 4, 5, 6. So this is cylinder number 4. And what we are going to do, I'm going to put my microphone right on the cylinder number 5, adjacent to the one we are putting compressed air in. And listen, I'm going to block the air. Hear that? That's proof that the air, you can feel it. I just know you guys can't feel it through the camera, but you can feel the air coming out of there. That's interesting. Why are we not also hearing it through the intake or exhaust? Because what I believe explains this, there's two ways that would happen. One would be a blown head gasket between the cylinders. Kind of not buying that, and that's because that's almost always going to be associated with an overheat. More likely, what I believe would cause something like this would be the piston banging into the valve and smashing the valve after bending it, smashing it into the cylinder head between the cylinders and cracking the metal between the cylinders. But if that were the case, with that valve being bent, I would have expected that I would also hear this through the intake or exhaust, depending on which valve did that, and I don't hear it. Let me try again. All right, now it's not through the intake for sure. Let me try the exhaust one more time. I do not hear it through the exhaust, so I will admit I have a little trouble explaining what happened there. Well, that means we're going to have to take this cylinder head off so we can see what is causing that. But let's do this. Let's jump over to cylinder number 6 and see if we also get air coming out here, indicating that we've had this happen in more than one location. Okay, we're plugged into number 6 here. See, our leak down's on high, but I'm not sure what our cam positions are. Exhaust valve is open. So just as a control, now that the exhaust valves are open, I'm just going to get under the car and I'm going to see if I can hear that leak down in the exhaust. So let me get down here. Oh, most definitely. Yeah. Let me see if I can give you guys a listen. I'm going to put the microphone right to the exhaust manifold. So you can hear the air going through the exhaust, which of course is normal right now, that exhaust valves are open. So what I'm going to do in this case, I'm going to use this ratcheting torque wrench to turn the engine over. Yes, that's right. I'm using a ratcheting torque wrench. I always get flack from the stupid moronic idiots who don't think independently. I can literally turn this engine over with my hand, okay? So there's probably 8 pounds of torque required to turn this engine over. This is a 250-pound torque wrench, you morons. So why is it that my turning the engine over with this torque wrench is bad for it, but torquing a cylinder head bolt to 180 foot-pounds is not bad for it? People are frickin' idiots, man. Besides, I don't use this as a torque wrench. This is just a cheap Great Neck one from AutoZone I use just simply because it's a 1/2-inch ratchet. When I do torque applications, I use a snap-on torque wrench. But anyway, all right. I'm going to turn this engine over using my ratcheting torque wrench, because I'm an independent thinker, which allows me to open up more possibilities because I'm not afraid of things I don't understand. And I'm going to turn this engine over.
My dad always said to use tools for the proper purpose, and he also said never buy a Ford, they suck.
All right, cranking the engine over. You can see the cams are moving. I just heard a change in the air pattern, so that's probably that I've now opened the intake valve. Let's take a look. Oh yeah, you definitely hear it through the intake. That intake valve is open now. And it is, so I'm going to crank it just a little bit more until both valves are closed. Hear that change? All right, I hear a change in the airflow. Let's take a look here. All right, intake valves are definitely closed, exhaust valves are definitely closed, and I hear a definite rush of air. Notice no compression in this cylinder. Where is the air? It is not through the intake. I'm going to go down under the car, listen at the exhaust. It's coming out the exhaust. Yeah, it sounds like it's coming out the exhaust. We'll give you a listen here real quick. Some of you guys are wondering why I'm not listening at the cooling system, and that's because there is water in the cooling system, and I would see it bubbling, and you would hear it bubbling, and it is not. So none of this is going to the cooling system. All right, well, at the very minimum, we know that we have some very serious cylinder head issues on bank 2. We're not doing bank 1 because I'd have to remove the intake manifold and all that, and quite honestly, it doesn't matter. Because I don't believe in replacing just one cylinder head on a car with a lot of miles, because otherwise you've got an imbalance where you've got your nice new reconditioned cylinder head on one bank, and then on the other bank you got your old original cylinder head. Very often the engine has idle problems and just doesn't run very well in that regard because of that balance with the differences in compression. So you know, really at this point still recommend a replacement engine. It's also actually going to be less expensive for the customer in that regard, quite honestly, if I just replace the engine with a used engine. But anytime you have a compression test or a leak down test that fails, at the very minimum that cylinder head's coming off. Well, strike that. I should correct that. Not on the compression test, because if the engine is out of time, then that doesn't mean the cylinder head has to come off necessarily. So if it's a compression test and the engine is in time and it fails the compression test, yes, then the cylinder head's got to come off at minimum. Leak down test with the valves closed, doesn't matter if the engine's in time or not. If it's leaking on leak down test, cylinder head's got to come off at minimum. What we haven't determined with certainty is there lower engine damage. That we have not been able to confirm. So rather than go through each cylinder and look at that, I think what I'm going to do is try a different method. And that method is I'll drain the engine oil and put it into like a pickle jar lid with a white reflective background. And you guys have seen me do this a lot in the channel. And what I'm looking for is evidence of a lot of bearing material, which actually I don't see. Also notice, by the way, no coolant in this oil. Again, this was not the result of a blown head gasket. What I look for, it will typically look very much like a glitter from an art project, and the oil is just full of glitter. It's unmistakable. And that indicates bearing damage. And the bearing damage isn't going to necessarily be specific to any one location in the engine. And that would be evidence of the fact that there's every reason to believe you've got bearing wear in the lower engine as a result of your failure. I don't see it here though. The oil's dirty, but it doesn't have evidence of bearing wear. So we haven't been able to conclusively show that there is a lower engine damage problem, such as valve punched right through the crown of a piston or something. But the fact of the matter is it doesn't matter at this point. I think the least expensive and most reliable solution is going to be a replacement engine. Also remember, the piston heads did crash into the valves. This creates a variable that we don't know the structural integrity of the piston crowns. If we were to get the engine operational and it has to face actual combustion temperatures and pressures and conditions, that is just an unknown condition that could risk doing cylinder head replacements and then immediately finding that you get a lower engine failure soon after, which would double the cost for a customer. So I think we're going to do a replacement engine on this. All right, actually it turns out the customer already beat me to it. I contacted the customer. He's actually fairly car savvy. He knew enough that probably his engine was toasted, and he already had been researching used engines and already has found one. So he is a friend of a very good friend of mine. So while I really don't do a lot of this engine replacement stuff anymore, I'm going to go ahead and work with him on replacing this engine. But I am still curious on what is going on there. What is the actual damage? So I think what I'm going to do is really quickly just rip that cylinder head out as quick as I can, and let's take a look at what is causing the results on that leak down test. All right, what was it I said in the last scene? I was going to yank that cylinder head out of there or something. Yeah, but anyway, we got a problem here, and that is there was no coolant. When I went to drain the coolant before removing the cylinder head, there was almost no coolant to drain. And the thing is, there was coolant in the reservoir, and the guy says the car didn't overheat, which I'm questioning now. But seeing the coolant in the reservoir, I assume there was coolant, but there was no coolant. And I did get this cylinder head off, and it's not quite what I was expecting. So let's take a look at the cylinder head. All right, so if we look on the cylinder head where I was expecting to see these horribly bent valves and everything, they actually look pretty good. Kind of zoom in a little bit on there. So our cylinder numbers are 4, 5, 6. And as we go along, I can assure you there doesn't seem to be an issue. So normally you would see the valve clearly not seating flush in its valve seat, and that doesn't appear to be the issue here. Well, actually, strike that. Exhaust valve. So these are 4, 5, 6, and there is an issue with the exhaust valve. See if we can show you there. So that explains why I was able to see the leak down go through the exhaust on number 6. We'll try to get you a shot of this. I don't know if the camera can catch this, but right here, there is some warp there with the valve, and there's a gap there. I can actually see through to the cylinder head. Actually, here, let me do this. Let me put some light into the exhaust port. There you go. You can see when I flash the light, you can see it behind the valve. So we have a leak in that exhaust valve, so that is consistent with what we have found with the leak down test. If we look between 4 and 5, I was expecting some kind of compromise here, and I don't see one. Oh, well, actually it's warped. That's going to be a warp there, but there's no crack. Let me get a straight edge. But before I do that, let's look over at the engine, because the thing is, there's no evidence that there was any interference with the pistons and the valves. The valves clearly were never struck by the pistons, even the one that has the warp there. But we would see that more clearly on the piston crown. So let's go to the car. And we're looking between 4 and 5 here. Well, there are some marks here, but that can't be from the valve. That must have been, well, that wouldn't have happened when I'm taking off the cylinder head, because this piston is recessed quite a bit. I'm not sure what these marks are here, if you can see them. Let me zoom in on that. Well, those are scratches in there, but they couldn't have been from the valves. What I'm looking for is if there is any kind of damage between 4 and 5 that would have allowed the compression to pass from cylinder 4 into cylinder 5 as we saw in the leak down test. And I don't see anything there. Let's take a look at the gasket. Okay, so this gasket, this would be 4, 5, 6. So we want to see, well, there's no evidence here between 4 and 5 of a major compromise in the gasket. The gasket actually looks fine. Huh. So, looks like no physical damage from the interference, which I was expecting was going to be really dramatic. If I'd have known it was just going to be some warp, I wouldn't have bothered with just taking the cylinder head off. Let's take a closer look here between number 4 and 5 at this warp here. I can actually see it. I can actually see it. It's kind of funny. It reminds me probably 7 years ago when I first started doing this stuff. I took a cylinder head to a machine shop where I measured like a 3/1000 inch warp or something like that. As soon as I set the cylinder head on the counter, the machinist took a look at it and he just traced around with his finger. Oh, right there. Yep, you got a warp right there. And I thought it was the most amazing thing I ever saw in my life. But when you do this a lot, it's amazing. You actually can get a sight and feel for it. Huh. Let's get a straight edge there and we can measure this warp. There's a huge, huge warp. That's clearly why my leak down was showing passage between these two cylinders here. Let's see if we can show you this without even using a feeler gauge. There we go. See all the light right here, all the light passing under the ruler. That's a massive, massive gap. And then by comparison, you look over in this area, you can see it's perfectly flat. Over on the other side, a little bit off camera view here. Right there, you can see no light through there. But right here, right between the cylinder heads. So that's why our leak down test showed as it did. Leak down test, pretty awesome diagnosis there, and everything is confirmed. This warp almost certainly is from overheating, almost certainly. Okay, what we're going to do is use a feeler gauge to measure that warp, and I'm actually going to use a 1/100th inch. I am very confident this is going to pass through there with no problem because this is the worst warp I've ever seen. So we're going to go ahead and do that and check it out. There's a little slight drag there, so I could go bigger. Certainly won't go through any other parts, but it passes right through that center. Not what we were expecting, but without question, that's a pretty serious warp. As a matter of fact, I wonder if the block is warped too. Let's go check out the block. I'm not going to be able to get a camera angle on that, but there is absolutely light passing underneath my ruler, not nearly as much as on the cylinder head. Let's try that same feeler gauge. See if this passes through. And it will not pass through, but there is a gap there. Let me try a smaller feeler gauge. Let's try something like a 6/1000 maybe. It looks like that might pass through. Just barely. And only at one point. Can't get it through there. And it won't go through any other point, but yeah, right through there. Just barely passes through. Okay, so that would mean that the block, the deck surface would need to be resurfaced. Also have to, well, I don't think you could shave that much off the cylinder heads. That's too much to take off of a cylinder head, I'm positive. So the cheapest way to go is still going to be a replacement engine for this thing. Alrighty, hey, I found a couple more broken timing pieces in the timing chain area there. So, you know, not sure which was the issue, the timing chain problem or the cylinder head problem there, but whatever the case is, my customer lied to me. He said the card never overheated, and it absolutely overheated. There was no question in my mind. So not really sure which happened first, but we definitely have damaged timing chain tensioner for sure. The timing chain was just barely hanging on, and the broken components, and also really massive cylinder head warp and also warp on the deck. So new engine, I believe, is the best thing for this. So that's what we're going to do, and Really sorry we didn't have the catastrophic damage with bent valves and maybe a piston crown poked through and all that, but it still explains the leak down test perfectly. I love that leak down test. All right, guys, that's it for this video. Hope you found this entertaining. We will see you next time, and congratulations again to our winners from the last video. Don't forget to send me your email address, and I will get you that free access to www.schrodingersboxqm.com. See you later, guys.